Hi guys, it's Mrs. Tranter, and I'm going to show you osmosis and the three types of solutions. When I was giving the notes, it was a little bit difficult to kind of imagine it for me, so I'm going to go ahead and write it and show you visually what happens to the cell when they're placed in the three types of solutions that we talked about. So hypertonic, hypotonic, and isotonic. So let me share my screen with you because I'm actually going to... All right, so let me move this. So again, you guys, this is osmosis. So the first type of, if I can figure this out. So the first type of solution we're going to talk about is a hypertonic solution. So the definition of that means it's a greater amount of solute, which is our dissolved substance, is on the outside of the cell. So I like to use numbers because numbers make it easy to understand. So I kind of drew a pretty generic picture, but this represents a beaker, and then the circle is our cell. So on the outside of our cell, we have 70% salt, 30% water. So we have a higher solute or dissolved substance than we do on the inside. So in comparison to 30% salt and 70% water. Now, keep in mind, the salt is going to be too large to move across the cell membrane, but the water isn't. So the water is going to do the moving. Keep in mind, the water is going to move in and out, but one's going to have a greater net movement. So one's going to move in at a higher rate or move out at a higher rate. So we are going to show you that. So since there is a lower amount of water on the outside than there is on the inside, the water wants to move out. So there's going to be a greater movement out than there is moving in. Okay, so more water is going to be moving out than moving in. So what is this cell going to do? This cell is going to shrink. Okay, so the greater net movement of water is out than it is in. So it's going to shrink. All right, so let's move on to the next type of solution, and that's going to be a hypertonic or hypotonic solution, excuse me. So a lower amount of solute on the outside than is on the inside. So I used the same numbers, but I just switched them. So now we have 70% salt, 30% water on the inside, and 30% salt, 70% water on the outside. Now, remember, salt is not going to move, the water is. So our greater net movement of the water is going to be into the cell because we have 70% of water in comparison to 30% of water. Now, there's still going to be some movement out, but it's not going to be as great. That means that our cell is going to swell, okay, and possibly burst. The last one that we're going to talk about is isotonic solution, and obviously this one is the easiest because it means they're equal on both sides, so equal on the outside of the cell and on the inside of the cell. So our net movement is going to be the same in as it is out, and that means that our cell is going to stay the same. Okay, so let's just review. So hypertonic means that we have a greater amount of solute on the outside. Our water is going to have a greater net movement out, and the cell will shrink. Hypotonic solution means that we have a greater amount of solute on the inside or a lower amount on the outside. It's going to have a greater net movement in, and the cell will swell. And then the last one is isotonic solution. They're the same on both sides, inside of the cell and outside. So our net movement is going to be the same. Therefore, our cell will stay the same as well. I hope this helps, and if you guys have any more questions on the three types of solutions, make sure you email me or call me. Thanks, guys.